This is an exponentials and logarithms question. Give it a go first, see how far you get, and if you get stuck on anything, then just skip forward through the video to see my hints for each part. So we're told that a scientist investigating the growth of a certain species of mushroom observes that this mushroom grows to a height of 41 millimeters in 5 hours. So height is 41 millimeters, and the time in which that growth occurs is 5 hours. And then we're told that he wants to model the height, which is in millimeters, t hours after the mushroom started forming by that equation below. So we have the right units. H is in millimeters, t is in hours, and then we also have an equation. H is k times 1 minus e to the minus a 12th t. Okay, and then we're told that t is greater than or equal to 0. K is a positive constant. And then it says, show that k is equal to 120, correct to 3 sig figs. So for part A, we're just putting in all of this information that we have here into the equation. And then so we get 41 is equal to k, 1 minus e to the power of minus a 12th times t. And then we will be rearranging for k. So I'll just divide everything by what's inside that bracket. So 41 all over 1 minus e to the power of minus 5 over 12. And then when you type this into your calculator, you end up with 120.3, which to 3 SF is 120. Part B. So we're given the equation, h is equal to this. That's to be used for the rest of the question. Okay, and then it says determine the value of t when h is equal to 90. We're going to work out what t is. Okay, in the form of ln 2. Okay, so then we're putting in this into our equation and rearranging for time. So then we get 90 is equal to 120 1 minus e to the power of minus a 12th t. So then I can divide by the 120. 90 over 120 is 1 minus e to the minus 12th t. 90 over 120 is 3 over 4. I'll move that to the right and move the exponential to the left. E minus a 12th t is 1 minus 3 over 4, which is the same thing as a quarter. So then e to the minus a 12th t is a quarter. I can now do natural logs of both sides to get rid of the e. So we get minus a 12th t is ln of 1 over 4. And then we can bring the minus 12 to the right hand side. So times both sides by minus 12. And then we get t is equal to minus 12 ln 1 over 4. So then if we look at the question, it wants us to give it in the form of a ln 2, which is not what we have here. We have a quarter. We want to somehow change that into 2. So then a quarter is 2 to the power of something. Think of what that something is, and then you can put that into here. So that would be minus 2. 2 to the minus 2 is 1 over 4. So then this becomes minus 12 ln 2 to the minus 2. And then we can use the power law to take out this minus 2. So it becomes minus 2 times minus 12 ln of 2. And that then becomes 24 ln 2, which is our answer. For part C, show clearly that dh dt is equal to this. So I think some students might find this a bit tricky. So the first thing you want to do is, well, you have this equation, differentiate it normally, but then what you'll find is that you'll end up with an exponential with a power of t in there, which is not what we want here. We want to have h instead. So once you've differentiated this, then you want to consider this equation and rearrange it. Once you've rearranged this equation for whatever you think is appropriate, then you want to sub that into your differential to turn the e to the minus a 12th t into h, which is what we have here. Okay, so then let's just first rewrite this out. So h is equal to, I'm going to multiply it out as well, 120 minus 120 e to the minus a 12th t. Now we're going to differentiate it. So dh dt will be 120 differentiates to make 0. The minus a 12th from this comes out when we differentiate. And those two times together to make 10. So then, now we want to use this equation that we have here. So, with the equation that we've got here, we can rearrange that for the e to the minus a 12th t. So then, I'll put that on the right side. So then, I'll bring the 120 e to the minus a 12th t to one side. So instead of dividing both sides of this equation by 120, I'll divide by 12 instead. And then the left-hand side becomes 10 e to the minus a 12th t. And that's the reason I did that is because we have 10 e to the minus a 12th t here. The right-hand side then becomes 120 minus h all over 12. And I can split that up into two parts. 120 over 12 minus h over 12, which is the same thing as 10 minus h over 12, and therefore dh dt will then be equal to, well, it was equal to 10 e to the minus a 12th t, and now that will be 10 minus h over 12, which is what we wanted, so that is our final answer for part C. So on to part D. Hence find the value of h when the height of the mushroom is growing at a rate of 7.5 millimeters per hour. So the key things from this question are, one, it's growing, that tells us something. Rate is the key word here. So think about what rate means in this question. If we know that the rate of growth of the mushroom is 7.5 millimeters per hour, that gives us an equation. Once we have that equation, then we can use what we've already worked out in the previous parts to then work out what h is. So first thing you want to do is figure out what rate means, get an equation using the 7.5 millimeters per hour and the fact that the mushroom is growing. So rate means you differentiate. So then we know that dh dt, so that's what rate means, the rate at which the height of the mushroom changes. We're told that it's growing, so dh dt will be positive. And we know it's growing at a rate of 7.5 millimeters per hour, so dh dt will then be equal to 7.5. And once we have that, we can use the fact that dh dt is 10 minus h over 12. We can equate these two things, and then rearrange for h. So h over 12 is equal to 10 minus 7.5. And then we can multiply by 12. So this is 2.5. H will then be 2.5 times 12, which will be 30 millimeters. So that is part D done. So on to part E. State the maximum height of the mushroom according to this model. So our equation is 120 minus 120e to the minus a 12th t. So you want to think about, what does this graph look like? You can start with t is equal to 0, what would h then be? And then think about what happens as t approaches infinity. So when t is 0, e to the power of 0 is 1, so the height will then be 120 minus 120 times 1, which will be 0, which makes sense. When time is 0, the mushroom has just started growing, its height would be 0 as well. So we have a couple of options for our graph. Our graph would either look something like this, or it would look like this. It wouldn't dip into the negative side of the graph because, well, it's growing, so the height wouldn't be decreasing. And the two exponential shapes that we could have that would fit this graph, which have a coordinate t is equal to 0 when h is 0, would be either that or this. The second one makes more sense because this suggests that the rate of growth just approaches infinity as time goes on, and the height approaches infinity. This makes a bit more sense. But let's see what happens when t approaches infinity. So if you think of a graph of e to the minus x, this looks like this. So that's effectively what we have here. The e to the minus of 12t, it's e to the power of negative some variable. The graph would be like this. The 12th just stretches it horizontally so it doesn't change much in the graph. This coordinate would be 0, 1. And as for this graph, as you can see that when x approaches infinity, the y coordinate approaches 0. So then e to the minus of 12t, as t approaches infinity, e to the minus of 12t will approach 0, and therefore the height approaches 120 minus 120 times 0. Or in other words, height approaches 120. So our graph will look something like this, where this is our asymptote. The equation of that asymptote will be h is equal to 120. So this is the height axis, and this is the time axis, and this will be our answer. H approaches 120.